have a question about the total maximum. So this is the theoretical number calculated for the heaviest athlete.
Yeah, so this is a maximum calculated from the function. So it doesn't orient itself around world records. It's just a scaling. Now, it is actually interesting that you bring this up because the question will be, well, the Q points for women are going to be lower than the Q points for men. Well, clearly, we've had different functions for the men and the different functions for the women. And men lift more than women do in general. So it cannot be directly compared.
Hi, Marianne. Welcome to Evidence Strong Show. It's my pleasure to have you. And could you briefly introduce yourself?
Hi, Alex. I'm so glad that you contacted me. Thank you so much for inviting me. My name is Marianne Huebner, and I am a professor of statistics and probability at Michigan State University. I've been competing as a master's weightlifter for about 7 years, and I also coach the students, the student weightlifting club. I became interested in weightlifting research topics where I thought there were gaps in the literature. And that then included performance development in youth, master's weightlifting, age, and the influence of body weight on performance, on weightlifting performance.
I'm very excited to have you. And today we'll be speaking about your recent paper, Comparison of Olympic-style weightlifting performances of elite athletes. Scaling models account for body mass. So there are weight classes in weightlifting, and there is a female division and male division, and recently additional division for transgender athletes. So why would we want some models to compare weightlifting results specifically?
Yeah, there's been a long history to try to compare weightlifting results across body weights because heavier athletes typically can lift more, and many nations can use these to determine the best male or female lifters and also to award best lifters in a competition or across an age category. Let me show you some picture that shows it really nicely how it works. These performance results from 2017 to 2020 IWF qualifying competitions. These are world and continental competition results. In green, you see the pictures, the performances for the women, and in blue for the men. Then I drew a line across. It's the 90th percentile. So it's at the top. It's not the world records, but it's the elite athletes. And so we can see that from the lowest to the highest, the performance increases. Now, it's very unlikely that somebody who weighs 50 kilos all of a sudden is going to be competitive for 160 kilos. But we'd like to see somebody who lifts much less than somebody at the high end is not necessarily a worse athlete. Can we compare those athletes? And we can also see that women lift less than men in general. There's some overlap. The thought would be, how can we compare the lifters at the lowest weight categories with the ones at the highest? So let me show you the next picture. This is just to illustrate it. So these are medalists, in those very same competitions, world and continental championships. So these are the gray dots were the actual performances and just fitted with a 90th percentile curve. Now, can we scale these performances so to turn this gray dot into a blue dot all the way across so that lifters at this weight categories can be compared with lifters at that category? And I'm looking for a way to scale these points so that overall the average will be horizontal. That means there will be a fair comparison. Yeah, so this can be used in any number of ways. For example, in competitions to find the best lifter overall. Within body weight categories, we don't have a problem because we have that exact performance within body weight categories for the medals, but across, we can only do it once it's scaled.
There were attempts before to do it. Why other models or what other ways of comparing athletes were maybe less successful?
So there are a number of methods that have been used currently and in the past. The most famous ones would be the Roby points and the Sinclair points. They are currently in use. Now, what they do is they use world records, both systems. World records is the final system. So Sinclair tries to find a curve only for 10 points. for women and 10 points for men for those world records. And the Ruby points is a scaling system that says, well, every world record gets 1,000 points and everybody else is proportional to that. That's not a bad idea. I'm going to show you. So these are the actual body weights, how the athletes weighed in, the males at the bottom, the females at the top. So one of the things that you can see here, there are these spikes. And the spikes means that the athletes try to be at the upper end of the body weight category because it might make a difference in their performance. You can also see a long tail in this distribution. That's the unlimited body weight class. The red points are the body weights at which world records were achieved. So one of the things to point out is you can see, well, we have all these world records at body weights that correspond to the weight classes, and then there's a big gap. And in the unlimited weight classes, the world records we set at the upper end. The athletes who are most competitive are the heaviest in this one weight class. That makes it a little difficult for any kind of statistical methods to fit, because you have so many athletes here that are not really competitive to get a world record. And the way it has been done in the past is with regression models. So you use these points and try to fit a best curve. Now, the question is, which points do you use? And many attempts have been made using the world records to find that as an attempt and fit a curve through it. The problem is we have many more lifters that are not world records, and world records may have been a doping problem, and then the world record changes, it gets reset, and so on. So can you really use this as a comparison? Now, if we try to use the Ruby points, these are the medalists, blue for males, green for females, and their Ruby points. And then I'm trying to find a curve to see, is this horizontal? So can I really compare somebody with the lower weight class with the ones with the highest weight class? And I certainly can for the world records because they're all 1,000 points. But then anybody below, that's not so easy. Yeah. And the main critic, it's a great attempt. So within weight classes you can compare, but then across weight classes that will be a problem. So for example, if somebody, let's say a man weighs 81 kilos and lifts, say, 340 kilos, that's about 90% of the world record in the 81 kilo class, and this person gains 1 kilo. As this person gains 1 kilo, he will be measured against the next world record. Not the same world record, but the world record in the upper next class. And that's going to drop his Ruby points without any change to the performance. That is one of the problems with the Ruby points. And the other problem is the world records change. So if I think the 73 kilo class, in 2018, the world record was 360 kilos, and now it sits at 364 kilos. So a lifter who weighs the same and does not change his performance, the Ruby points drop because it's a reference to the world record. So we'll see these wild behaviors if I was trying to fit it across the body weight categories. That was one of the motivation to look at. And we come up with a system that doesn't change so rapidly.
So Ruby is not good for comparing across weight classes. Before, Sinclairs were used. So how do they shape?
Yeah, so Sinclair is a good system, other than that it is bound to the world records. There has been a problem with how do we compare things. Yeah, here we have, I created this figure. These are the same athletes and the same performances. These are the medalists of those world and continental championships, and I used the Sinclair points adjustments. And the question was, can we create a point system or a scale system so that these points would be comparable across the body weight? And we get better than what was before, but not quite, because this on this left hand side, the figure A, that's the males. We can see, well, the athletes in the lowest body weight class actually will have Sinclair points below the horizontal line. Then at the little higher weight classes, they will have Sinclair points above the horizontal line. And then later on, I think the heaviest will be above that line. So the gray shaded area, this is confidence bands. We cannot be perfect, but does the majority fit across, does the horizontal line, is that covered by this confidence bands? And for those Sinclair points, that's not the case. So for this region, they are all above the line. That would mean, if this is the case, that lifters in this body weight range maybe favorably have Sinclair points. So they might have a better chance at winning an overall medal. For women, it looks worse. Women is actually quite hard to fit. So we also see the same phenomenon, but even stronger. So the lightest weight women would have more favorable results with the Sinclair points. So that was the motivation for the Q points. Can we come up with a better system? And as I mentioned, many have tried. Don't know whether that's the final answer that we came up with, but it looks better than the Sinclair points because the red points are the scaled points. And if I draw a horizontal line, this horizontal line is covered by these gray bands, confidence bands for the men. For the women, we can see that has a little bit of a problem, but the confidence band covers the horizontal lines. So it's an improvement over the Sinclair points, and it's an improvement over the Roby points in the sense that it can compare across the body weights.
Could you tell us a little bit more how the Q points are calculated?
Yeah, it's actually a simple formula. I thought it was going to be much harder, but it worked out. Here's the formula. What we did is we tried lots of different functions of body weight, so including functions that hadn't been thought of before, but very systematically a class of functions that cover a whole range of shapes. And then the formula is as follows. The Q points are calculated. You take the total from the weightlifting competitions and you multiply it with some maximum total and divide it by a function of the body weight, the actual body weight. So I need the total from the weightlifting competition and I need the weigh-in weight. This reference maximum is different for men and for women. It was calculated as the maximum of these functions at the upper end of the body weight range. So the function can be easily calculated in calculators or in Excel spreadsheets and competition software, and some competition softwares have already done that. I also have web applications to add it to try your own Q points. I prepare to bring the link, but it's very quick to calculate.
Gonna put the link in the show notes.
Yeah, right.
I have a question about the maximum, the total maximum. So this is the theoretical number calculated for the heaviest athlete.
Yeah, so this is a maximum calculated from the function. So it doesn't orient itself around world records. It's just a scaling. Now, it is actually interesting that you bring this up because the question will be, well, the Q points for women are going to be lower than the Q points for men. Well, clearly, we've had different functions for the men and the different functions for the women. And men lift more than women do in general. So it cannot be directly compared. So the first question would be, well, can't we just change this scaling maximum so to make it equal? Well, unfortunately, we can't. We can for the world champion level athletes, but then everybody will want to use it for the national or for regionals, and that would not be the same maximum, the same scaling point. So at this point, we're stuck with separate formulas for men and women.
So would Robbies be less susceptible to this? Because they go from 1,000 points. So then 1,000 in male class versus 1,000 in female class should be the same. So these could be compared across sexes.
Right. So that is the proportion. I am already working on a system that would be robust across the body weights, but also can be compared for sexes. It turns out it's not that easy because I've observed this in several occasions, but the curve for the men is steeper for the weight than it is for women. So we see this in the model that, here we go. So these coefficients are different between the men and the women. So it is not easy to use the same formula, although it has been tried for men and women. Very typically, it's either going to be a good fit for the men or a good fit for the women. But I believe that something can be done, maybe not with Q points, but with a different scaling system. And I'm working on that process right now.
Will it work for all age groups?
That is an excellent question. And that is the question that applies to Robbie points and to Sinclair points and everything else.
Yeah.
Because we think about, just from a statistical perspective, what we generated a formula, a system that is generated for 20 to 30 year olds, because the peak of the age of peak performance is in the mid-20s, and elite lifters, those who compete in the world championships and the Olympics, and those who can set world records. So why would any system that's developed for this very special group be applicable to any other group, any other ages? So when we think the peak age is mid-20s, why should this formula work for 15-year-olds or 70-year-olds? That is nevertheless done with the Sinclair formula, and it's not clear how well it works for the different ages. So any kind of formula that one can come up with needs to be tested carefully at different ages. And fortunately, I have good collaborators who help me with this project, and we're trying it in different levels, namely, like, what does it work in national championships? And we've done it Iceland and USA, and it works, fortunately. So it is comparable, makes sense. I've also tried it in master lifters. That also works. I was a little surprised, but very happy that also works, because as long as this body weight curve makes sense for an age group, then it should be applicable. So it will also work for junior lifters, like ages 18 onwards. But I would not recommend any of those systems for youth. The reason is that youth, with each year of age increase, they will get better, but they will also get heavier. They gain weight and they get better overall. So it's a different phenomenon that needs to be considered for that. I actually have done some work on that, and I have a system, but we're using that only in local competitions. So that is across the age. So my answer would be, yeah, you can use it for masters, and for juniors and for seniors, but please don't use it for youth. The formula will not be stable for the lightest, for very lightweight, like 30 kilos or so. The other question that I brought up in the beginning with the body weight, we have the heaviest, the unlimited body weight class has such a large spread. It's from 110 kilos to 180 kilos for men. That's the same range that we have for the limited body weights. So that makes it difficult for the development of formulas, and because in a sense they are outliers. And so older models have actually excluded the unlimited range. So there are a number of formulas around that have not even considered the unlimited range. But Sinclair does, and my formula does, and other formulas do that also. The women weightlifters performances, you could see they have actually much larger range, much larger variation in their results. And that's why it's difficult for both Q Points and for Sinclair to come up with a good formula. And Q Points have done a little bit better on that, especially for the women.
Do we know why?
Yeah, I have some hypotheses about that. That is, the women weightlifters have, Sinclair was originally developed when there weren't that many women in the weightlifting field, but it's been updated every so often. But the women participation has just really increased. So what can be is that actually with the increase of the participation in women, actually the performance have gotten overall better. So we haven't reached a status quo that might still be, improve in heaps and bounds as participation changes, while it is much more settled with the men, even though, the world records can still improve. But for women, they have more chances of getting medals at different levels. So that is the higher range. That is one theory driven by the participation. And the other is that the larger variation of women has been seen in many other physiological measurements. So it's not just in the performance of the weightlifting. I have some key points here. Well, Q Points are really easy to use, and they're open access. That means it's not tied to me or anybody else. The formula can be used by anybody. The formula can be updated by anybody. So we still recommend, especially with the change in participation, that the Q Points update every so often also perhaps aligned with the Olympics cycle. But this could be done by an IWF committee, for example. Who wants to exclude, say, doping cases and which years to include. So it can be done. The algorithm is available on how to derive that formula. That's number one, easy to use, and it's open to use. The second point is Q points are an improvement over the existing approaches. Existing approaches favor some body weight ranges, or there can be large differences in small changes of body weight. And lastly can be used for juniors, seniors, and masters, but not for youth.
Yeah, that's a big improvement because it makes it easier. You type Formula Ones into this competition software and you can use it across all the athletes and open competitions, excluding the youth athletes.
Right.
That's very handy.
One thing I would like to mention is that many systems used only world records or just the top 3 athletes in each bodyweight category. Q points used all the points. So all the performances in the World and Continental Championships were part of this formula. Thus, I believe it could be more generalizable than those who only use world records.
All right. So you think that Q points are applicable for national performances, regional competitions, club competitions, and so on?
Right.
Awesome. Okay. What comes next?
2 things. So one is the mixed team that's been on my mind, and I've already made some progress on that, but I could compare men and women, but not yet across the whole range of body weights. The other is one should consider, I would really like a different separate formula for youth, especially for children. Before puberty, there's no difference between boys and girls of what they can lift. But what might happen is it's the same of what I've already developed, is that it's a system of points, both age and body weight at the same time.
That sounds complicated.
As we said, for youth, the older you get, the better you get, but also your body weight changes. And so the system that I've worked on with a statistics colleague from the UK is already published and it's out. So also open access, but it's not easy to change. We have age and body weight multipliers for ages 8 to 20. So that works well. But still, my main goal is checking more national competitions to see whether it's really as well across all the national and regional levels. And the second is to have a scaling model for mixed teams.
I have 2 more questions. One is, what is your favorite color?
Okay, Michigan State University. I choose green.
And the second one is, if people want to look more into your work or ask you any questions, where they should go and find you on internet.
Oh yeah, there are multiple places. One is Open Science Framework, OSF, where I put this work. There's the code and there's the results, there's the formula, there's an Excel spreadsheet with the formula, and it also has my contact. And the other is my MSU email, huebner@msu.edu.
Awesome. Thank you so much. It was my pleasure to finally meet you through the Zoom.
Thank you so much, Alex, for keeping trying.
No worries.